Hi there. So in this video, I'm going to be explaining to you the way I have carried out keyword clustering using machine learning algorithm. I talked about it a couple of days back on LinkedIn, and I'm going to share this video now with everyone who's interested to learn about this. So keyword clustering is a little different, first of all, from keyword grouping. So keyword grouping is where we try to semantically and lexically classify keywords. So this is basically important from the point of view of creating coherent ad groups for better quality scores, so on and so forth. This is keyword clustering, which is a performance metric based clustering. So as to understand from a performance point of view how different kinds of keywords are doing, and therefore once the clustering is done, we'll be able to take decisions based on the clusters as to what kind of CPCs to target, what kind of outcomes we can expect from them in terms of conversion rate or any other metrics. So the sheet that you're seeing here has three metrics corresponding to each of the keywords, and they are CPC, CTR, and CTR. You could have taken any other metrics, but these are the very useful metrics. And you can also take things like ROAS and BOAS maybe. So this is actually the final outcome of this sheet. This is a very simple sheet. This is only going to do all its magic in the back end in the output. This is all it's going to show. It's going to show the cluster descriptions, the cluster definitions, you can say. So three clusters have been made. Um, and as I will show in just a moment, you actually have the ability to check provide the number of clusters. The user has that option. So cluster zero, for instance, has a certain average CPC, average CTR, and average conversion rate. Same thing for cluster one and cluster two. So the average values for each of these metrics across these clusters has been provided, and that is the basis that forms the basis basically of the cluster descriptions of the clusters themselves. So let's actually see how this works. I'll just get rid of these couple of columns here, which consists of the output. And then I will click on this button here. This is a menu bar button where I will hit on this thing called k-means clustering. And I'll just come to that in a moment. Let's just look at the output first. So you'll see that it gets populated in columns E and F. So it's the same thing once more that we have got. And this clustering is basically done using machine learning. So that machine learning model that we're using is called k-means clustering. That's here mentioned on this button. And this is more advanced, certainly much better and more advanced than just using the manual sort of gut feeling or sort of a visual scanning kind of a method that I've usually seen media buyers employ in their approach towards keyword clustering, keyword classification when it comes to performance-based classification. Keyword grouping, on the other hand, like I just said at the start of the video, is a different thing. And that can also be done using machine learning, but that's called, natural language processing or NLP or even more advanced methods than that. So those can be done. For that, you will actually have to use some sort of LLM. And for LLMs, like any GPTs, for instance, and you will have to use if it is about ChatGPT, then you have to use the OpenAI API key for that. So that requires that integration process that's generally not free. So that's a separate thing, and make a video on that as well. But for now, for the purposes of this video, this is more about the keyword clustering, which is a performance classification. So once this is done, the first question is how to interpret it, and secondly, how to use this data, right? How to use this output that you've got. So the second one should be clear to any media buyer. You do any kind of performance classification over anything, whether it is campaign, keywords, search terms, whatever it is that you do it upon. You'll do it to better target your campaigns in order to take better decisions. So, for instance, you can put the top performing keywords, define based on the definition that you choose. So, for instance, if you look at these clusters here, there's one that has a high conversion rate. And you'll see that the conversion rate is over 1, which means that it's over 100%. And that, of course, is not correct, right? It cannot be. And we'll come to that. There is a problem with this data set, which I've deliberately taken. The problem has been built into this data set, And this is actually a real data set, but the problem has been there for a certain reason. I'll come to that in a moment. But my point is that you will look at the conversion rate, you will look at, or you can look at CPC, whichever is more beneficial to you, whichever is more important from the business point of view. It, of course, varies from business context to business context. So depending on your contextual requirements, you will decide what is the top performing one, and you will then put those the designated clusters into that bucket, into that campaign, so on and so forth. You can have two or three such campaigns. You can have campaigns based on these clusters only, and as we'll just see that these clusters actually have a significant implication there. CPCs are on the higher side, conversion rate on the higher side, and then there's a medium CPC and medium conversion rate, and there is low CPC and low conversion rate. So all of them have their own sort of pros and cons. So accordingly, you can decide what kind of target CPA to keep, what kind of target, if you're using manual bidding, then what kind of max CPC to set. So that way you can just decide, as to what kind of bidding strategy to have. So there are a lot of ways you can play around with this, classifying across campaigns, deciding, on the basis of bid strategies, that you can actually use this data, this information, this outcome. So that's the second part, and like I said, this part should have come naturally to any experienced media buyer. Now, the first part is the more relatively difficult one, which is to just look at this, cluster descriptions part and just understand what has really happened here. Because I'm sure even those watching this video, to you also it's going to take some time, right? You will actually have to look at this data. You'll have to see the relative classification. I mean the relative variation in the numbers, where it is more, where it is less, and then decide, okay, so this basically means that this is high CPC and high conversion rate. This means that is or this one, the first one here is medium CPC, medium conversion rate. This one's a higher one, and this is the medium one. This is the lower one. So that sort of textual description has to be the way you understand. That is the human way of interpreting things. So that is generally difficult when you get this sort of an output of clustering. Now, this is basically called cluster interpretation, and the best way to do it is through visualization rather than through any kind of numerical distinction only. And that distinction is going to be done through something called box and whiskers plot. So we're going to come to that. But before that, I just wanted to say that this is, of course, sort of a dummy exercise, even though it's based on real data. And I'll come to the part, like I already said, that there's some deliberately misleading data to actually see why it is useful and why the visualization that we're going to use is actually going to be useful to understand and figure out any kind of problems with the data, right? So that's very useful also with the approach that I'm going to show. So do watch it till the end. The second thing, of course, is just for the purposes of this video, I've chosen 3 clusters. So you'll see that when I hit this button here, it actually tells me to decide and tell this algorithm what is the number of clusters I want. So in this case, I chose to go with 3, and that's a very common number. The thing is that it might vary, right? In many cases, you'll see that it's not 3, it can be just 2, or it could be more than 3, depending on the nature of the data set. So that is something that actually has to be tested. And in this method that I have here, so first of all, this is using AppScript, and like I said, this is a machine learning algorithm. So it's actually difficult to incorporate all the aspects of machine learning within Google Sheet alone. Okay, Google Sheet is generally not very good at that. Google Sheets API, but this has been done keeping in mind the limitations of Google Sheets. But still, it is quite k-means clustering was doable in this case. But anything at more advanced, like for instance, even the box and whiskers plot that I'll just show in a second. This is where the outputs are. It's an issue with the outputs. I'll just show them from the Python plot where they actually are. So yeah, so this is the Python plot, and these are basically the outputs. And I'm coming to the discussions on them in a second. My point is that these visualizations, for instance, were not possible in Google Sheet alone, and they had to be therefore created through Python. This entire classification process can also be done using Python, as I will just show in a second. But the bigger takeaway from this, the key takeaway, is that the number of clusters is something that you will have to provide. And this actually can also be decided algorithmically, or you can actually figure out using machine learning itself. There are ways within k-means algorithm and its approach to decide or to figure out how much is the how many is enough, right? So, or how many is too many. So k is basically the number of clusters in k-means clustering algorithm. And while you are providing k equal to 3, you don't really know whether 3 is too many or too less. Okay, and this is a very, very important point. I hope I'm able to convey this. Even if you're uninitiated in machine learning, it is important that you understand this point. So there are actually ways. There's something called the elbow method. I've actually discussed this in some of my previous videos where I've, for some reason or the other, touched upon k-means. I've used k-means. I use it very regularly, and I've touched upon this topic previously also. So I'll link to those previous videos in the description. So do give those a watch as well. So that being said, that part being out of the way, so now actually let's jump into the code. So this is basically the Python code. I'm not going to walk you through every bit of it. We are first importing the libraries that are required for it. Then we are uploading the data. This is the same data set that you're looking at here in this sheet. And then basically we go to decide what are the columns. We just decide what are the columns that we need for clustering. So um, there are a couple of things that require to be done because the CTR and the CV are basically in percentage formats, so they have to be converted into numerical or number format, and that is important in order for the algorithm to work properly. And then you also have to extract the columns that you actually want for clustering. So in this case, of course, it's easy because you have only got those 3 columns, those precise columns that you're going to use for clustering. But your data set may have a lot more columns, right? So you have to extract those those columns from the data set. Um, and yeah, so if you are going to use this Python code, for instance, this is DFY code. This is done for you, so you can use it. This is probably the part that you should be looking at. So here you should be naming the columns exactly as they are in the sheet, okay, in the Google Sheet or whatever is your source of data. So for instance, I have uploaded a CSV file. So you will have to give the column names exactly. So if these were, for instance, in lower case, it would not work. Okay, so they're very case sensitive, and you have to use it exactly the way it is in the source file. So then you just clean the data, and cleaning in this case simply means to, as I said, to convert the percentage of the data that is in percentage format into number format. And then you start applying the k-means clustering, as simple as that. And random state equal to 42 functions. So there are a lot of parameters here, as you can see, for different functions and everything. So if anyone wants to learn Python, they can just look it up, or you can get in touch with me also. I'm fairly familiar with all of this code, and um, you can also take the help of LLMs or GPTs to generate the code. The only problem is that it will almost certainly contain a lot of errors at the start. So you'll have to keep prompting a lot. So you'll have to know what to prompt basically, and understanding the code is crucial because there's going to be so many things that can go wrong here. Trust me. And this is not just a simple create a little widget on a website, that sort of a thing, because that's relatively easier. There's not too many conceptual things associated with it. So Python code is actually easy, to be honest. Python's syntax and Python's flow is easy. It's really the concepts behind data science that you have to understand. Otherwise, just the code alone will not be enough, and you'll probably end up making mistakes. So the whole point of this video, in fact, is interpretation itself. So that's why let's focus on that. So k-means has been defined here, as you can see, and random state equal to 42, for instance. I'm pointing this out because even if you're not very familiar with all of this, but you're using this DFI code, this is useful because this means that every time we run the code, this randomization state being equated to 42 means that you will have the same output every time. Otherwise, the output keeps changing. Okay, and the output can keep changing because these algorithms carry out a lot of simulations. They have their own internal processes, and therefore every time the approach will be a little different, and therefore the outputs can vary. So in order to prevent that, that's why you provide that parameter there. And then you basically fit the clustering data, and the clustering data is simply the columns to cluster. You know, so it's basically called a data frame in Python's parlance. And then you calculate and display the cluster definitions. As simple as that. You have applied K-means clustering. From there, the clusters have been defined, and then you just start printing them. So the first step of the process before the visualization is to actually get the clusters themselves. And this is exactly the same as you will see is the that is there in Scribble sheet or very close at least. Let's see, 0.69. Yeah, it's exactly the same. So the clustering is done in two different ways. You can see, and the output is the same. This one has been done using Apps script. This is within Google Sheets. This one has been done using Python, which is completely separate from that. There is no connection between these two here. At least for now, that's not how I've done it. But yeah, that's always doable. But my point is that K-means clustering is a simpler algorithm. You can do it within Google Sheets, but if you go for more advanced algorithms, you can't. You will have to use Python, and if you want to connect it to Google Sheets, you'll have to use Google Sheets API in order to get the data into Google Sheets. Now, so we have the cluster definitions, and now we'll go to that part that we were just talking about at the start of the video, how to visualize and how to interpret it visually. So we're going to use this thing called box plot or box and business plot. So you can read up a lot about it. I have previously shared a document, on LinkedIn and elsewhere that contains the different kinds of visualizations that are required in marketing analytics. So that's definitely worth a read. And this kind of visualization was also covered there. So CPC distribution by cluster, CPC distribution by CTR distribution by cluster, and CVR distribution by cluster. So you can understand what's going on here. All the three clusters are there in the x-axis for each of these plots. And in the y-axis, you basically have the distribution of that particular metric, of the values of that particular metric within each of these clusters. So for instance, let's look at CPC first, and we can see how the CPC values vary within the first cluster, within the second cluster, and in the third cluster. So 0 is, by the way, one of the clusters, so not to get confused with that. So that's the first cluster, for instance. This is the second one, and 2 is the third. Similarly, we have the CTR distributions for each of the clusters and then the CVR ones. Now, you can understand how easy this becomes visually, right? So we'll go back to one point. Remember what I said at the start of the video and what you can also see for yourself. The conversion rate is more than 1, the average here. And that's because if you just go to the conversion rate column, there'll be a few ones which have 200% conversion rate. Okay. And there are, in fact, I think CTR ones also, which are, yeah, CTR ones also, which are above 200%. And that's because if you just take this data has been extracted from Google Ads. And if you do this, sometimes we will see that this is going to happen for keywords which have had a very small number of impressions or clicks. So as you can see, there are no clicks and impressions columns here. If they were there, this will actually get proven. That's how it's happening. For a small number of clicks and impressions, sometimes you'll see that the clicks exceed the number of impressions, even though that's completely counterintuitive and doesn't make sense. But sometimes it happens. I've deliberately included that just so as to make this point clearer, how this visualization really helps. So this is an important point to understand. Sometimes what happens is 1 or 2 clicks, and it depends on the kind of industry, the kind of business, basically. Sometimes you may be, running search ads, for instance, for an e-commerce business where the AOV is on the higher side, or at least there are some products which have a very high AOV, and they can significantly skew the entire distribution, skew the entire output. Okay, so you might have like 3 impressions and you might have got 4 clicks. That's what the data is saying. Obviously, you've got more impressions. But from those 4 clicks, you might have got like huge number of, or maybe 1 click and you got a huge AOV, and that can completely skew the distribution. And that's why this kind of distribution is, this visualization is so useful. So you can see what's happening. For instance, let's now. So how to read this? Okay, so let's do this step by step. So let's take first cluster. Okay, first cluster is in, let's take cluster 1. So that's the second cluster technically. So cluster 1 has got the highest CPC, right? So generally speaking, as you can see here, so there are two things that you need to understand about the box plot. So even without understanding box plot, you can pretty much see that this entire thing is above the other two. So obviously its range is somewhat higher, right? Everything about it is above the rest of the clusters. Now this box here, this rectangular box which encapsulates this entire space, that basically represents the core zone, and that represents the interquartile range, basically. So that represents, this basically is the Q3. Okay, that's 75 percentile of the data, and this bottom one is the 25 percentile of the data. So this is the interquartile range, and this red line here is the median. Okay, and the median is obviously not going to be always in the center, as you know, because that's going to be skewed in favor of that region wherever there's more spread of the data, right? Basically, more data points. So that's basically the box here, as simple as that. It's interquartile range. The red line is the median, and that green uh, triangle, the little triangle or arrow, whatever it is, you can see that that's basically the mean. That's the average. Okay, the arithmetic mean of the entire distribution. And then you also have something called the outliers, and this is, for instance, this is the maximum value. So in this case, there are no outliers. The outliers are typically given by these, little black circular points here. As you can see, some are here, some are here. None are given in this case. Okay, so this is the maximum value. This is the minimum value. These are called the whiskers. So this is the box, and these are the whiskers, and together they're called the box and whiskers plot. So you can see the CPC for cluster one is the highest. So that's one feature. That's one way to interpret the cluster one. Let's actually look at the other two metrics now. So when it comes to CTR, you'll see that there's a very, very close, a lot of similarity between cluster one and two in terms of CTR. But even then, you can say that it's probably just a little bit lower, right? Or a little bit higher. I mean, the minimum value or this quartile here, the 25% quartile is a little above, and this value is probably the average value is probably a little lower. So even the median is lower. So you can actually say that this is a sort of a medium value because there's another one which is much lower, right? So this is the highest sort of CPC. This is the sort of medium-ish CTR, and then it has the highest CVR clearly, right? You can see the median value, the average value. The median is on the low side, but the average value is on the higher side, and generally the distribution spreads to higher values as well. Okay, so for each of these clusters, you can actually see and make that sort of an analysis. For instance, cluster 0 here, which is the first cluster, you can say has the minimum CPC ranges, and it has the minimum CTR ranges and also the minimum CVR ranges. So you can see that there is a logic, right? Just from looking at this this distribution, this visualizations plots, you can actually clearly understand and to interpret that there is a clear meaning, there's a clear concept behind the clustering, right? So it's not just random. Now, of course, this was a small data set and you only had 3 clusters. And you can say that, hey, Kishloy, I don't really need this visualization. I can just take a look at this data and decide for myself what's really going on. Just mind the fact that this was a dummy demonstration. This was just a demo sort of a thing. You can have situations where you have much more clusters, and even if not more clusters, but certainly more variables, right? So you only have 3 variables. The good thing about clustering is that it can take in multiple variables, right? So k-means clustering, that is a power of machine learning algorithm. And in that case, you will have to rely on some sort of visual method for interpretation. Otherwise, it will become very difficult to understand, okay, what does it mean? Like, what does it mean to have cluster 0 in that case? So, just like we understood that it's a higher CPC and a higher ish sort of conversion rate, that is the sort of textual, that is the conceptual understanding of the cluster that you need to have. Otherwise, it will just be numbers, okay, and it will not be actionable. So that's why this is so crucial, and it's something that I've done in my previous videos, but I thought that I should be adding to this one. So if you've watched any of my previous clustering videos, this is, which has also been on a similar topic, like the keyword clustering. I may have done it on some other topics, even I've forgotten now. But there are a lot of keyword clustering videos or clustering related videos that I've created, and I've talked about k-means as well. So definitely, connect those with this one going forward. So I hope this was clear. And one thing that I just said, the fact that the conversion rates are 200% and 200% CTR as well, all of which don't make sense. That is also something that you can see in a jiffy, right? So when these percentages were converted into percentage into decimals, so you can see they actually go on to 2 as well, right? That's what they have been converted into decimals, so it becomes 2, anything like 200%. So you can see that there are some values in that sort of a range. Anything above 1, some of these values are not correct, right? So that is something that you can easily see from the distribution, because that simply doesn't make any sense. You can't have conversion rate which is greater than 100%. So I hope this makes sense, and you will have to sort of do your own reading if required. But I think this is a very handy method. Media buyers can really benefit from using this sort of an approach. So yeah, I'll leave the links to these couple of things, both the Python plot as well as the Google Sheet. And yeah, and I'll look forward to any kind of questions that you might have. And if you have any, definitely leave those in the comments. I'll try to help you out and answer them as much as possible. And yeah, see you in the next video. Thanks for watching.